Hi, Math 85. This is Dr. McGathy, and we are wrapping up section 8.3 and the semester by solving equations. So let's look at these more difficult ones where we have variables on both sides of our equation, and we might have fractions or decimals involved as well. This first example, 3 halves x plus 5 equals 1 half x minus 3. Again, especially when things are complicated, I like to give myself a visual, split my workspace into two sides here. I need to first move the variable term over so that it only appears on one side of the equation. So I will undo whatever operation is connecting this term, 1 half x, to this side of the equation. So I've got really what it is addition. Even though you see the subtraction here, think of it as this is really like a plus negative 3. So it's addition that's connecting these two terms. And the 1 half x is positive. So what I needed to do is subtract 1 half x from both sides. Basically add the opposite of this term to both sides. All right, so now on the left-hand side, I've got 3 halves x plus 5 minus 1 half x. So I like to line the like terms up one beneath the other so that I can mentally do 3 halves x minus 1 half x. So 3 minus 1 is 2. This will be 2 halves x plus 5 equals, and on the right-hand side here, 1 half x minus 1 half x, of course, that adds to 0 because that's the way I wanted it to be. And so I'm left with negative 3 on the right. Okay, so now I'm going to just rewrite this because 2 halves x is really just 1x or just x. X plus 5 equals negative 3. So now I can undo the plus 5 by subtracting 5 from both sides to end up with x equals negative 3 minus 5 is a negative 8. You can always check your answer by plugging negative 8 into the original equation. Let's see how that looks. 3 halves times negative 8 plus 5. I'm just rewriting this, plugging in negative 8 where I see an x. Let's see if that's equal to 1 half times x, which is negative 8, minus 3. Okay, 3 halves times negative 8. Again, with fractions, you imagine that negative 8 is over 1. And then 2 and 8 have a common factor of 2, so I can sort of reduce as I go here. Divide by 2. 2 divided by 2 is 1. Negative 8 but divided by 2 is a negative 4. So 3 times negative 4 here is negative 12 over 1. 1 times 1. Plus 5. Let's see if that's equal to half times negative 8. What's half of negative 8? That's negative 4 minus 3. Okay, negative 12 plus 5 gives me negative 7. Negative 4 minus 3 is also negative 7, so it checks out. So we can always check our answers. Also, if you want to do these types of problems by hand, and then when you're done, come in with your calculator to check your answer, that would be acceptable too. So if I did 3 halves times negative 8 plus 5, that evaluates to negative 7. Now let's see if the right-hand side, 1 half times negative 8 minus 3, that also evaluates to negative 7. So you can use your calculator wisely here. All right, next problem. This one has decimals. 3.4x plus 4 equals 1.6x minus 5. I will do what I've done like in the past. I want to move all the x terms to one side of the equation. So I'll undo this addition. Again, remember, you can think of subtraction. This is really like plus a negative 5. Undo the addition by adding the opposite or subtracting 1.6x from both sides. Lining your like terms up underneath like terms. So 3.4x minus 1.6x. Let's go ahead and do that subtraction. I'll get 1.8x. Then you have the plus 4. that's on the left-hand side, equals -5 on the right-hand side. Now I'll go about solving this more simple equation by undoing the addition first. So -4 to both sides. I'm left with 1.8x on the left, and -5 minus 4 is -9 on the right. And now I can divide both sides by the coefficient here. This is 1.8 times x, so I'll divide both sides by 1.8. So I'm left with x equals, and now would be a good time to use your calculator, -9 divided by 1.8, which gives you a -5. Let's go ahead and check our answer here too. We'll be doing 3.4 times x, which is -5, plus 4, and we want to see if that's equal to 1.6 times -5 minus 5. So let's use our calculator to help with that. 3.4 times -5 plus 4. Remember, your calculator knows about the order of operations, so it'll do the multiplication first and then do the addition. So this becomes -13. Let's see if we get -13 on this side. Oops, I didn't write that down. 1.6, not 16. Got 1.6 times -5 and then minus 5. And over here I get -13 as well. So everything checks out. My answer is correct. All right, let's do a few more of these more complicated problems. One's involving the distributive property now. 3 times x plus 2 equals 18. So here's where I'm going to need to simplify the left-hand side first. I'll simplify it by distributing the 3 into the parentheses. 3 times x is 3x, plus 3 times 2 is 6, equals 18. Now that I have it simplified, I'll undo the plus 6 by subtracting 6 from both sides. I get 3x equals 18 minus 6, which is 12. And now I'll undo the multiplication by dividing both sides by 3. I'm left with x equals 12 divided by 3, which is 4. Let's do another one. Over here, I'm going to simplify this side. Again, I like to imagine two sides of my equation here. Distribute that 4 into the parentheses. 4 times x is 4x. Then minus the 4 times 2, which is 8. Plus 5 equals -3. Now I can combine like terms here. 4x minus 8 plus 5 gives me a -3. Equals -3. Now I'll undo the subtraction by adding 3 to both sides. This leaves me with 4x equals -3 plus 3 is 0. And now, undoing this multiplication, divide both sides by 4. I get x equals 0 divided by 4, which is 0. Lots of people get nervous when you end up with 0, so maybe you will check this one. 4 times 0 minus 2 plus 5. Let's see if we get -3 out at the end. Okay. And again, I wouldn't use your calculator for any of this except for maybe at the end to help you check your answers. So 4 times 0 minus 2, or you could have just written -2, and then plus 5, and I get -3. So it does check out. So let's do a few more of these. Negative x plus 5 equals 7. I'll put in my line, my imaginary line here. So this is like a -1 here, which you'll want to distribute into the parentheses. I like to think of distributing the negative sign. You're like negating the whole thing. So it changes the sign of every term on the inside. -1 times x is -x. -1 times 5 is -5, or you could just make it a -5 equals 7. Now I'll go ahead and solve for x by undoing the subtraction. So I'll add 5 to both sides. Get -x equals 7 plus 5 is 12. And now if you remember, I like to think of these as a negation. negative, I want to have x by itself, but I have negative x. So I'll negate both sides, basically change the sign of every term you see. Or if you like to think of it as dividing both sides by -1, that's fine too. X equals -12. Let's do this next one. 8 minus 2 times parentheses 3y plus 5 and parentheses equals 0. And again, I hope that you stop the video and try these on your own and check your answer at the end. First thing we'll do is distribute this -2 into the parentheses. And my favorite way to do this is because you know when you're subtracting that minus is kind of associated with that next number there. So I like to think of this as plus a -2, so that the negative goes with the 2 when you distribute over the parentheses. So let me rewrite what I have here. 8 plus -2 times 3y will give me a -6y, so I'll write minus 6y. -2 times 5 is a -10, so I'll write minus 10 equals 0. Now I can combine these two terms, plus 8 minus 10, so I'll be left with -6y, because the negative goes with the 6y, plus 8 minus 10 is minus 2 equals 0. Now I can start manipulating the equation. I'll add 2 to both sides. I'm left with -6y equals 2. And then I'll divide both sides by this coefficient, -6. This leaves me with y equals, and then 2 over -6. So this won't divide evenly, but it does give me a fraction, positive over negative. I can write the negative on the outside, and I can reduce this fraction. 2 goes into both numbers. So -1 over 6 divided by 2 is 3. Y equals -1/3. All right, we'll do these last two problems now. 3 times x minus 2 minus 5 equals 4 times parentheses 2x plus 1 and parentheses plus 5. I'm going to need to simplify both sides of these equations here, of this equation. So I'll distribute in the 3 on this side, and on this side I'll distribute in the 4. And I'll write in the helping line here for myself. 3 times x is 3x. 3 times minus 2 is minus 6. Minus 5 equals, and on the right hand side, 4 times 2x is 8x, plus 4 times 1 is 4, then I have the plus 5. I can simplify further. Minus 6 minus 5 is minus 11. So I've got 3x minus 11 equals 8x, plus 4 plus 5 is plus 9. Now I have an x on both sides of this equation here. So I'll need to collect them all to one side. I'll go ahead and subtract the 8x from both sides, lining up like terms. 3x minus 8x gives me a -5x minus 11 on the left. And on the right, just have 9, because 8x minus 8x adds to 0. Now I can finally use our familiar steps. Add 11 to both sides to get -5x on the left, and 9 plus 11 is 20 on the right. And finally, undo the multiplication by dividing both sides by -5. You get x equals 20 divided by -5 is -4. All right, and we'll do one last problem together here. This one involves fractions, and I'll need to simplify this left-hand side. I will distribute that 1/2 into the parentheses. 1/2 times 6x gives me, half of 6 is 3. It gives me 3x. Minus 1/2 times 2, half of 2 is 1. Equals 5 minus x. Let me go ahead and put that helping line in. And now, I want to collect all my x terms to one side of the equation. So here I have a minus x. I'll plus x to both sides. I get 3x plus x is 4x minus 1 equals 5. Now I'll add 1 to both sides to undo that subtraction, which leaves me with 4x equals 5 plus 1, which is 6. Now I'll undo the times 4 by dividing both sides by 4. I'm